afterwards. All right, so today we're starting chapter 4. Okay, it's on classifying, well, this one's on classifying triangles. But we're going to go over different triangle properties. So just starting off is classifying triangles by their angles and their sides. So to classify a triangle by the angles, we have an acute triangle. Okay, that triangle has 3 acute angles. Okay, so all 3 of your angles would have to be acute, meaning they are less than 90 degrees. Okay, so your picture here, I can draw a triangle like this. None of those angles are greater than 90, so it would be an acute triangle. Our next type of triangle would be an obtuse triangle. Okay, and an obtuse triangle has 1 obtuse angle. Okay, so just 1 obtuse angle. Our picture. So my 1 angle right here is greater than 90 degrees. Just to be sure, I'm going to label that as 120, just so you know it is greater than 90 degrees. Okay, so far we have acute and obtuse. The next type is a right triangle. Okay, a right triangle has 1 right angle. In our picture here, we put that box in that angle there to show that it is a right angle. Okay, so acute, all 3 angles are acute. Obtuse, you have 1 obtuse angle. Right, you have 1 right angle. The last one is equiangular. Okay, for that one, all of your angles are congruent. Okay, all of your angles are congruent, meaning all 3 have to be 60 degrees. Okay, our picture here, all 3 of our angles would have to be 60. Okay, so those are our 4 different types when we're classifying by angles. Okay, any questions on those ones? I'm sure you've seen most of those before. Okay, next I want to classify triangles by their sides. Okay, so the first one is a scalene triangle. For this one, you don't have any sides congruent. So no sides are congruent to each other. They're all different lengths. So if I draw in a triangle here, and I label this side 3, this side 4, and this side 5. Okay, all of those sides are different lengths, so it would be scalene. An isosceles triangle, you have 2 sides that are congruent. Okay, my picture. And I can label 2 of my sides with those dash marks just to show that they are congruent to each other. Last one is an equilateral triangle. Those are triangles with 3 sides that are congruent. So all 3 sides are going to be equal to each other. So again, my picture here. To label all 3 sides, I'm going to put that dash mark through all 3 to signify they're the same. So when you're classifying, make sure you read the directions because it might say classify by its angles or it might say classify by its sides. And if you see a right triangle but it says classify by its sides and you write right, that's going to be wrong. Okay? Just because it's a right triangle, you're not classifying by its sides. If you say right triangle, that's by its angles. Does that make sense? All right, bottom statement. An equilateral triangle is also an equiangular triangle. Okay, so if you have all of your sides the same, so equilateral has to do with the sides of your triangle. If all of those are the same, then all of your angles have to be the same as well, which is equiangular. So if it is equilateral, it has to be equiangular, and vice versa. Okay, it can't be equilateral and a right triangle. It's not possible. Can't be equilateral and an acute triangle. Well, that is kind of possible, but it's also equiangular. Okay? Questions on classifying by sides? All right. At the top, we want to classify each triangle as acute, equiangular, obtuse, or right. So we're looking at the angles as we classify these triangles. So number 1, I have all 3 of my angles are 60 degrees. How would I classify that triangle? Equiangular. Number 2, I have an angle of 40, 45, and 95. That is obtuse. Okay, 95 degrees is greater than 90. So that is an obtuse angle. Number 3, I do have a 90-degree angle in there. So this would be a right triangle. Number 4, I have an 80-degree, 50, and a 50. All 3 of those are less than 90 degrees. So this would be an acute triangle. No? Number 5, I have 30 degrees, 50 degrees, and 100 degrees. Okay, 100 is greater than 90. That makes it an obtuse angle. So this is an obtuse triangle. The last one here, I have 70 degrees, 55, and 55. All 3 of those are less than 90. So this would be an acute triangle. Okay, again, I was classifying by the angles, so I wanted to make sure I was looking at the angle measures within that triangle. Any questions on any of those classifications there? All right, for 7 to 10, we're classifying these triangles by their sides. Okay, so before I even get started classifying these, I'm going to look at my picture here. I see a lot of these dash marks in my sides. Okay, that means those sides are all congruent to each other. Since this side ED is 8 and it has one of those dash marks in it, that means all the sides with a dash mark would have to be 8. Okay, something to kind of look for in your picture. Okay, so again, we're classifying these by their sides, so you're not looking at their angles, looking at the sides. I want you guys to classify these 4 triangles. Okay, so talk to each other in your groups. Classify those 4 triangles.
Scaling.
Yes. So going over these problems, number 7, we're looking at triangle ABE. Yes, this triangle is a right triangle, but we're not classifying it by its angles. Okay, if I look at all the sides in that triangle, they're all different lengths, meaning this would be a scaling triangle. Okay, scaling meaning none of your sides are congruent to each other. Looking at number 8, we have triangle EDB. Okay, so this triangle formed right here. 2 of my sides are 8. The other is 8 times the square root of 2. So I have 2 sides that are congruent to each other. So this is isosceles. Number 9, looking at triangle EBC. From E to B is 8 times the square root of 2. Then I have 8. And then E to C would be 16. Okay? All 3 of those sides are different lengths. So this would be a scaling triangle. Okay, so to get that side, you'd have to add both of those together to get the total length. Okay, then number 10, we're looking at triangle DBC. All 3 of those sides are 8. Since they're all equal to each other, this is equilateral. Okay, so make sure you are reading those directions. In that first part, we classified by the angles. In that second part, we classified by the sides. Okay, so make sure you're being aware of that. Any questions so far? All right, so in number 11, we want to find x and the length of each side of triangle ABC. Okay? We're given triangle ABC is isosceles. Okay? Isosceles meaning 2 of your sides are congruent to each other. We're given those congruent sides. Okay, that means I'm going to label my picture. So segment AB, this one right here, is congruent to segment BC. Now, yes, they don't look like they're congruent, but we're told they are, so they are. Now, what I want to do is find x first, and then find the length of each side. Okay, so since this is isosceles and these 2 sides are congruent, we can set them equal to each other. So 4x minus 3 is equal to 2x plus 5. From here, I can solve for x, so I'll subtract 2x, add 3, and divide by 2. Okay, so x is equal to 4. That was one part of my problem. Now I also need to find the length of each side. So I need side AB. So to get side AB, I'm going to plug in 4 for x. Okay, so I'll have 4 times 4 minus 3. Okay, so I just plug in this 4 for x over here. It is 13. Okay, then we need to find BC. So you could plug it in, but I already knew AB was equal to BC, right? So that should also be 13. Okay, then the last side, AC. Plugging in 4 for x again, I have 4 plus 2. That's 6. Okay, so these problems have two different parts. You need to find x, and you need to find all three sides of your triangle. Any questions on 11? All right, looking at 12, again, we want to find x. Move up a little here. We want to find x and the length of each side. Now, triangle FGH is equilateral. Okay, since it is equilateral, that means all three of your sides are congruent to each other. Now to set up an equation, I don't need to set all three equal. All I need to do is pick two sides and set them equal. Okay? Since it's equilateral, you can just pick any two sides and set them equal to each other, and you should get the same answer. So I'm going to choose FG and FH. Okay, so I have 3x plus 10 is equal to 4x plus 1. Now you could have also set 4x plus 1 equal to 5x minus 8, or 3x plus 10 equal to 5x minus 8. Okay, you should get the same answer no matter which ones you set equal, since it is equilateral. So when I solve for x here, I should get x is equal to 9. And I want to find the length of each side. Okay, so FG, I'll plug in 9 for x. So I have 9 times 3 is 27, plus 10 is 37. FH, again, these are equilateral, so if you did this correctly, if you plugged in 9 for x, you should again get 37. Then the last side, GH, again, if I plugged in 9 for x, I should get 37. Okay, so I found x and all three sides. So when it's isosceles, you have to be careful about which sides you set equal to each other. If it's equilateral, you can just pick two to set equal to each other and solve.
Okay.
All right, do number 13 for me, please. Are you already done with that one?
Can I write my joke now?
Is it appropriate?
Yes.
It's so appropriate.
Extra appropriate. It's extra. How we do? Right. I'm getting Connie, can you read that? Can you read
Yeah,
that?
kind
You
of.
guys are having a stroke.
Needs to be bigger and needs to be neater.
Stop it, guys.
You look like my cousin.
What is that? Why is it reaction to
Stop.
Okay.
You spelled coffee wrong.
Is that really? Oh,
Connor, you remember do it right nice and right rough.
Kenzie, please don't talk to me ever.
Hey, be nice to each other, please. All right, so for 13, you're given RS is equal to TS. So these two segments are congruent to each other. That means I can set 9x plus 2 equal to 6x plus 8. Okay, so when I solve for x, I should get x is equal to 2. Okay, so x should equal 2. Then I need to find each side. So RS will plug in 2 for x here. So I have 18 plus 2 is 20. For TS, since those were equal, should also be 20. And RT, if I plug in 2 for x here, I have 6 minus 1. That's 5. Okay? Any